Hi everyone. We are presenting our paper, Advancing Visual Grounding with Scene Knowledge, Benchmark and Method. We target at the visual grounding task. It aims to locate an object referred to by a description text in an image. It has emerged as a prominent attractive research direction in the vision and language field. For this task, the input is an image and a query text, and the model is required to output the bounding box of the referred object. Take this for an example. We want to ask the model to output the bounding box of the black glasses in the image. Our goal is to introduce a more difficult task requiring vision-language reasoning. Take a motivating example. If we require the model to find Jake's wine glass, the model will have no idea about who is Jake. Therefore, in our paper, we introduce scene knowledge to the traditional visual grounding tasks. By jointly understanding the scene knowledge and the image, we can now find who is Jack and locate Jake's wine glass. It allows us to testify the reasoning ability of existing vision language models. Next, we will introduce the background, the benchmark, the empirical study, and the conclusion. In the past few years, a variety of datasets have been proposed for visual grounding. We propose a taxonomy of existing, generalized VG datasets along with the proposed dataset based on types of queries, as shown in figure. The datasets of the first type are for grounding categories, or we say object detection. It uses fixed categories as queries. One of the most representative examples is the MS COCO dataset, which contains 80 categories, e.g., person, bicycle, and pizza. The second type is grounding phrases. The most distinct characteristic of this type from the first type is that it is an open vocabulary grounding problem instead of using fixed categories. The last type is grounding free text expressions. For example, a white cushioned chair with a gray pillow on it. In general, expressions in these datasets are written according to the visual appearance and spatial location of an object. However, the grounding queries are too simple and it might not require the complicated reasoning for the vision language models. This will lead to the situation that a vision language model might degenerate to a purely vision detection model. There are also some supporting study. Take the study from Luo, for example. It studies many factors that affect the performance of existing VG models. They found that a simple language model, e.g., LSTM, can achieve pretty good, even soda, results in existing benchmarks. They concluded that, as a vision and language task, visual grounding is less impacted by language prior. This can be observed from the table. So how about proposing a new benchmark to allow the model to perform complicated reasoning? Next, we will introduce the SKVG benchmark. To construct the benchmark, the first thing is to collect images. To facilitate and ease the writing of a text story, we identify three significant aspects a qualified image should fulfill. 1. Humans are the main body of a story. A satisfying image is better full of multiple characters with interactions in order to create complex and dramatic stories. 2. Objects are also essential and necessary to complement the details of a story. 3. Scenes are the third factors we cannot ignore since the scenes determine the background and starting point of stories. Complex and real scenes like theaters, classrooms, and parks can inspire diverse stories. Therefore, we select movie scene images from the Visual Common Sense Reasoning dataset. The next thing is to annotate the datasets. This is the UI for our annotation tool. For the scene knowledge, the annotators are required to write a story that is related to but beyond the image content to make it challenging for text understanding. For query annotation, the annotated queries should be relevant to the knowledge. Then it should not be ambiguous. Or we say the corresponds should be unique in one-to-one mapping. Finally, we expect the queries should be diverse, covering as more categories as possible. In addition, we curate a test set of 3 difficult level. A higher knowledge-related but lower visual distinguishable query expression deserves a more challenging grade. For example, in this sample, the first query, the painting in Hedda's hands. Although it is related to the scene knowledge, but since there is only one painting in the image, It would be easy for the model. Therefore, we will classify it into the easy level. For the medium level, the queries need the reasoning of the model but not require very complicated reasoning. For the hard level, it requires the model to fully understand the images and texts to find the target object through complicated reasoning. Next, we conducted empirical study on the SKVG benchmark. The question is that, is it difficult for existing models? The answer is yes. Existing VG approaches, including one-stage and two-stage approaches, achieve around 16 to 36% accuracy. Next, we proposed simple baselines to further study the benchmark. The first one is an one-stage approach, Knowledge-Embedded Vision-Language Interaction, KVLI. In this approach, we embed knowledge into the image before the image-query interaction. Given the image and the knowledge, we encode them into features and then embed the knowledge features into the image features using cross-attention. After that, we perform the querying on the knowledge-embedded image features. The second approach is a two-stage approach. It uses a pre-trained model, GLIP, as the backbone. We curate an input prompt template and then perform various analyses on the GLIP backbone. This is the experimental results. We will explain them step by step. The first finding is that the scene knowledge can help the KVLI model but not too much. The second finding is that the model cannot well utilize the knowledge if not fine-tuning GLIP or linear probing GLIP. Next, we found, when fine-tuning the model, the GLIP model can well utilize the scene knowledge and achieve 70% accuracy. The fourth finding is that we can further improve the performance by incorporating linguistic knowledge. Finally, we will conclude our study. In this study, we focus on the benchmark and conduct empirical study on the proposed benchmark. For benchmark, we propose SKVG, a visual grounding dataset with scene knowledge. For empirical study, we testify the performance of existing approaches on SKVG and introduce two baselines and study the performance effects in various settings. Thanks for your attention.